In this problem, we want to try to shift some of the weight, so more evenly distribute the weight of the trailer over the four wheels of the pickup truck. And we do that essentially by adding an internal torque at the hitch, by using some chains and a kind of a lever arm to generate an internal torque here that will try to cancel out some of the weight, the changes in weight acting on these tires here. So I think we could probably, what we want to basically do is cancel out the torque due to FD, and I think we could probably have done that in a simpler way by just looking at what FD was and figuring out what the moment that it was generating over here, and then figuring out what MD needs to be to cancel that. But I went through and just solved the problem from scratch, and so we have F the sum of the forces here on the pickup truck, and the sum of the moments on the pickup truck, and now we have this MD here, so it's in the clockwise direction. I wrote positive here, so it's a negative here. And so then we have, for the entire pickup truck and trailer, we have the forces in the forces from the tires must equal the total weight. And again, I'm using this as half the weight here. These are half the weights, since this is the load just in one of the two tires at each point. So we can have, and then we have a moment equation for the total thing, for the trailer and the truck. And again, we see that FD and MD cancel out. So here now we have four equations and 5 unknowns. We have F, B, C, and D. Let's see here. Yeah, B, C, and D, Y, and then F, A here. And now we have MD as another unknown, but we can use that to add another constraint equation. And so what they ask us to do is to make sure that the change in force on the tires, on the front and the back tires of the pickup truck, are the same. So that gives us another equation that right down here, that delta FB equals delta FC. And that will allow us to solve for MD. So we can solve for FB, okay? And I solve for it, generally speaking, in terms of the weight of the trailer and the weight of the pickup truck, or the weight of the trailer and the pickup truck, and then this moment. And then we know FB naught is when the trailer is gone. And so when the trailer is gone, FW1 is gone and MD is gone. So we just get this term. So that we can figure out the change in force on B is just this and this. And then on C, we have again these are the C is the front tires of the truck. We can see we have generally, in terms of the weight of the trailer, the truck, and the moment at the hitch. And then for FC naught, when we get rid of the trailer and the hitch, we're just left with this term. So we can find delta FC. And what we can do is basically delta FC is going to be FB, get rid of that, and FC, get rid of that, is delta FC. And so we can see that if we multiply through by this 99, we get 24 times the weight, or half the weight of the trailer, minus 32 times the moment in the hitch, equals minus 6 times the weight of half the weight of the trailer, plus 14 times the moment at the hitch. And so we know the half the weight of the trailer, and so we can find MD, and that is 973 foot-pounds. And then we know the moment arm from the bar spring that attaches to the hitch and to the chain. And so we want the tension in the chain, so we need to divide by the length of that moment arm, which is 1.7 feet. And so we get that that is the tension in the chain is 572 pounds. And then if we look at what the weight on the trailer FA is now 1,070 pounds on each of the tires on the trailer. On the back tires on the truck, we have 709 pounds on each tire, and on the front tires, each tire has 870 pounds. And what we did is we wound up adding 65 pounds to each one to each tire on the pickup truck. And what we can see if we look compared to the previous problem, so here we see that the weight of the trailer is now the force in the trailer tires is much bigger here, because now the trailer tires are carrying almost all the weight of the trailer, and instead of the truck carrying it. So we can see that the force, the load on the rear tires is now much less than it was before, but the load on the front tires is more. But the change is 65 pounds in each one of these. So we add 65 pounds, and if we subtract 65 pounds, that would be what the normal loads on the tires would be when there's no trailer involved.